Hi everyone, I'm Negin Arzadeh, student number 21009398. In this part of my ITEC413 project, I'll be explaining buffer overflow attacks, one of the oldest but still relevant software vulnerabilities today. A buffer overflow happens when a program tries to write more data into a memory buffer than it was meant to hold. Think of a buffer as a small container. When you pour too much, it spills over. But in computers, that spill can overwrite other parts of the memory. This can cause crashes or, more dangerously, let the attackers take control of the program. It mostly affects the languages like C and C++, where memory isn't automatically managed and boundaries aren't strictly enforced. Here's a simple example. Suppose we declare a character buffer of 10 bytes and use the get function to read the input. If the user enters more than 10 characters, the input spills over the memory areas assigned to the buffer. An attacker can use this override critical memory like the return address, the location, and the program jumps back to the after function ends. By replacing it with the addresses of their own code, the attackers gain control over the system. Now let's talk about real incidents. In the Morris worm, which spread in 1988, was one of the first major internet worms. It used buffer overflow to infect systems and brought down around 10% of the internet. That's huge for the time. In 2003, the Slammer worm exploited the buffer overflow in Microsoft SQL Server. It spread rapidly and caused a serious internet slowdown and system outages. Even today, embedded systems and IoT devices are often vulnerable due to outdated codes. The damage from a buffer overflow can vary. At the low end, it might just crash a program, but at the high end, it can allow attackers to execute arbitrary code, like opening a backdoor for installing malware. They can also escalate privileges, gaining root or admin access. And since many critical systems, including operating system and hardware drivers, are written in C or C++, a single buffer overflow in the right place can compromise an entire system. So to prevent buffer overflow, the first step is to use safer functions like fgets functions instead of gets, because they limit how much data is read. Also, modern compilers add protections like stack canaries, which detect if memory has been overwritten before executing dangerous operations. ASLR, address space layout randomization. It randomizes memory locations to make it harder for attackers to predict where to inject the code. DEP or NX bit marks memory as non-executable, stopping code from running in data-only areas. And finally, using modern languages like Python and Java, which manage memory automatically, can virtually eliminate this risk in many applications. Buffer overflow may seem like an old school attack, but they're still highly relevant, especially in legacy and low-level code. With proper memory management, compiler protects and secure code habits, they can avoid it. Thank you for watching my presentation. Buffer overflow, I hope this helps you understand how serious but preventable they can be.